Hello everyone, welcome back to part 2. As you saw in part 1, we started with a table that had all of the data already put in. Students are typically better with that than having to create their own, so we want to make sure we push them into the next phase. However, part 2 is one that is done with you providing an example and working with the students. As you look over the concepts that we're covering here, you might realize that students might not find a lot of these probability concepts challenging. But there actually is something the students do find challenging. This. Students find this challenging. Or maybe this. It's these abstract formulas that really don't hold a connection to what's happening in a particular problem or context. So students might not find the tables that challenging at all. The method we're using in this activity is based on a hypothetical 1000 tables. You can use any number as your base, so the hypothetical 1000 table is pretty common. You could also use 10,000 as a goal, being that we'd like to get accuracy without losing the ability to quickly be able to create the tables. These are linked to other folks, so I'll give a shout out here to Stephen Strogatz, Gerd Gigerenzer, and others. The big piece as you're looking at this, though, is that we're connecting natural frequencies, which is whole numbers, how many of something, instead of formulaic probability. And that formulaic probability is tied to maybe more traditional probability coursework, where you have P of A is equal to some decimal representation, 0.125, let's say, whereas in a hypothetical 1000 table, you would look into that area for the particular event and maybe see 125 people out of the 1000 total. So again, same concepts are going to be there. It's just going to look different. Now, Gigerenzer pointed out in one of his books that the research showed learning probability in this non-traditional way provided longer retention and understanding than just using these formulas. Having to memorize the formulas ended up being the sticky point because your memory can't always remember them even a month after you've covered them. And you've probably seen that with some of your students. So as we take a look, we're going to do the example with the Cologuard. This is a product that people can receive in the mail to be able to provide them with a test to see do they have colon cancer or not. Looking at the data from the Cologuard website, they've got a 4% overall rate of colon cancer at some point in time in a person's life. But we also have pretty interesting information about false positives and false negatives that can occur. What we're going to do is take a moment to kind of fill this table out to kind of demonstrate how this works. Now, again, if you have experience with this, it's going to be pretty quick for you. We're going to use a hypothetical 1000 table here, although you're welcome to use 10,000 if you prefer. But we're going to do 1000, so the first thing is we put the 1000 in the box at the lower right. Now that we've got our grand total of 1000 people, again, numerical frequency, how many, of that 1000 people, we know from the information provided that 4% should have cancer. That's 1 in 25. So multiply 4% by that and put that in the has colon cancer column at the bottom. Okay, we'll write that number in. And now taking a look across the bottom, you can see the grand total still has to match, so a quick subtraction allows us to fill in the number of people who do not have colon cancer. The study provides us with 13% of people without cancer had a positive result. That's a false positive. So let's take a look in that category. Now we need to make sure that we're selecting people who do not have colon cancer. So let me highlight that column here for us. And we know that 13% of these people did receive a positive result. So we're going to multiply 13% by the total from that column and just put the result in the appropriate square. Let's type that number in here. Oh, and notice, some of you might be pointing out, hey, I've got a decimal at the end. Again, we're talking about natural frequencies. And think about that as you're rounding this off. We're off by maybe zero point 0.4, zero point 0.6 out of 1,000 at times, so it's not a major piece. You can choose to keep the decimal place in there, or you could choose to round. I'm going to go ahead and round to the nearest whole number so that we have a whole number of people and it keeps the context. All right, once again, you'll notice one missing box. The grand total for the column still has to fit, so go ahead and fill in that missing box now. And then we move over to the 8% of people with cancer that have a negative result. So now we're talking only about people who have colon cancer. So highlight that column, and we know that 8% received a negative result. Again, this is a false negative, but in the appropriate square, take 8% of that total and write the number in. And while you're at it, since you're probably getting pretty good at finding the missing square, go ahead and fill in that top number as well to complete the column. And looking from left to right, now that you've filled out the pieces in the middle of the 2A table, you can go ahead and find the totals for Cologuard test positive and Cologuard test negative. And you can do a quick check to make sure they all add up back to the grand total of 1,000. So that's a pretty quick way to come up with all of the pieces you will need to answer pretty much any question that you ask about this situation. So now that we have the completed table, you'll notice the questions that are being asked do allow students to look at the table and find certain probabilities, but there's also some of those conditional pieces coming back in. So we know some of the probabilities going one direction, like 13% of those who don't have colon cancer receiving a positive. So we have these conditions coming on. Now we're going to go back and kind of switch that around. Some of you will recognize this as, a Bayes theorem type question, but you notice I didn't use a formula. There was no formula needed for this. I don't need a huge complicated piece. As a matter of fact, if I fill out this table, it's much quicker to see where the components fit together in the Bayes theorem formula. So take some time with this to make sure that your students are understanding, one, how to create the table, and then from the created table that they could answer any questions that are provided. You could even ask them, if you want, to create a few questions of their own. What other questions could be asked about this situation? And near the end of part 2, you might notice there's another table, completely blank, where we ask students to recreate the table, this time using 10,000 in the lower right, and see if you get kind of the same numbers. Now, if you've rounded previously, those numbers will be off by a tiny bit. But what you'll get a chance to see is 1,000 or 10,000 in terms of getting to that value that you want. This is a quick way to do it, and the results between the 1,000 and 10,000 table are almost the same, if not exactly the same. So in my class, when I'm doing this, I will often have students ask me, does it matter if I'm using 1,000 or 10,000? And it might, depending on your homework that you might have built into your learning management system or perhaps some other course product. So depending on the requirements for that, if you know that the student has to give out to so many decimal places, you may want to encourage them to keep the decimal places in the table, even though it takes a little bit away from the numerical ideas and a whole number of people. Once you finish up doing this table for the first time, a completely empty table, students are filling it in with you, you're talking your way through it, I think what you might notice is that students might not find it quite as off-putting or quite as complex as what you were doing previously if you tried to ask similar questions with formulas. I've found students find it fairly intuitive, and again, they find it kind of fun. So I hope this goes well for you. Continue working through the module. We got a few questions for you after this. All right, off you go.